I'm gonna wait to see if it's recording, like always. I think today I'm gonna do the Italian thing because it's been a long time since I haven't done this, and I don't wanna stop completely. And I also think I'm not gonna spend a lot of time here. I'm gonna spend probably half an hour or 1 hour only because I'm tired. I'm trying to reset or not reset, but change my sleep schedule. So going to sleep earlier. So I don't know what's the right expression, but for whenever you don't have enough sleep. But that's how I'm feeling right now. But I wanted to stream so I can structure the third video. I filmed the two first videos for the series of teaching people JavaScript and Python. And I'm debating on whether or not to put animations or more complicated things in the editing. And I think so far I'm leaning a lot more towards not putting anything and just doing the most basic edit possible. So pretty much just cut mistakes that I make or some airtime between words, things like that to make the video faster. But I don't think I'm gonna edit or do animations or this kind of stuff because it's gonna take too much time. And it's also gonna be very difficult, a lot more difficult than I thought it would be to teach this stuff. I've been watching some other videos on remembering the stuff that I learned about the computer, this playlist here.
So in previous videos, we've
from this guy, and then watching videos about the heap, the stack, and things like that. And I'm also gonna have to watch a bunch of videos about the operators. I think I'm only gonna talk about the assignment operator directly, and then the rest of them are just gonna say that is basically just like math, because I think it's probably a waste of time to explain one by one all the different symbols. With the exception of the coalescence operator, I think that one is worth it. Because, and then obviously the parts of JavaScript like the equal signs, this triple equal, true equal, stuff like that, that does make a difference and is a little bit more annoying. And I'm probably going to leave this for later after explaining a bunch of other things. Yeah, but what I'm thinking about doing on the third video is to... first, let me do the Italian thing before I get started with this stuff. Otherwise, I'm just gonna start doing the thing and end up not doing the Italian stuff. I think I'm just gonna play poker today, play tournaments. So that's why I don't wanna spend a lot of time here, because if I start the tournaments later, then they usually take 8 hours or 11 hours to finish. So, and I don't wanna go to sleep very late because when I start waking up earlier, and I'm gonna start another diet on Monday or Tuesday. I went to a nutritionist and she told me to follow for 20 days, eating at specific times and things like that. And then she made me do some exams for testing stuff on the blood and taught me a bunch of different stuff. Yeah, my main goal is pretty much mental capacity. That's the thing that I told her that I was focused on. So she told me to follow this strictly, and then hopefully I can hire someone to cook all the meals. I sent a message to them, but they still haven't responded. So, but I'm planning to start that tomorrow or 2 days after, regardless of whether or not they respond to me. And then based on the things that she
Va.
told, I'm gonna have to wake up early to follow.
Fisso.
Fisso.
Set, unchanging.
3.
3.
3.
Desiderare.
Desiderare.
Desire.
Aria.
Aria.
Air.
Bene.
Bene.
Well.
Anche.
Anche.
Also.
Giocare.
Giocare.
Play.
Piccolo.
Piccolo.
Small.
Fine.
Fine.
End.
Mettere.
Mettere.
Put.
Casa.
Casa.
Home.
Leggere.
Leggere.
Read.
Mano.
Mano.
Hand.
Portare.
Portare.
Carry.
Grande.
Grande.
Large.
Compitare.
Compitare.
Spell. Words.
Aggiungere.
Aggiungere.
Add.
Anche.
Anche.
Even. Also.
Terra.
Terra.
Land.
Qui.
Qui.
Here.
Devo.
Devo.
I must.
Grande.
Grande.
Big.
Alto.
Alto.
High. Tall.
Tale.
Tale.
Such.
Seguire.
Seguire.
Follow.
Atto.
Atto.
Enact.
Perché.
Perché.
Why.
Chiedere.
Chiedere.
Ask.
Maschi.
Maschi.
Men.
Cambiamento.
Cambiamento.
A change.
È andato.
È andato.
He. She went.
Luce.
Luce.
Light.
Tipo.
Fifo. Cipo.
Kind. Of thing.
Spento.
Spento.
Turned off.
Bisogno.
Bisogno.
Need.
Casa.
Casa.
House.
Immagine.
Immagina.
Image.
Provare.
Provare.
Try.
Noi.
Noi.
Us.
Di nuovo.
Di nuovo.
Again.
Animale.
Animale.
Animal.
Punto.
Punto.
Point.
Madre.
Madre.
Mother.
Mondo.
Mondo.
World.
Vicino.
Vicino.
Near.
Costruire.
Costruire.
Build.
Se stesso.
Se stesso.
Himself.
Terra.
Terra.
Earth.
Padre.
Padre.
Father.
Okay. So what I'm thinking about doing is I'm gonna start off with the binary. I'm gonna write. The problem is that this stuff is too small, but yeah, whatever. So I'm gonna start with this, and then I'm gonna do an arrow here. To explain. Yeah, I have to think about what is going to be the best way. What I'm thinking about it is not on this video, but on the next video after this, to take some code, to create some simple code in Python and JavaScript, and then put the code here, and then at each line of the code, I show the tree of information until it gets to the point that it exists in the final format. And the reason why is because I want to explain where each thing is coming from and how it works. And I think the main fundamental principles that I have to teach are the stack and the heap. I think those two are essential for everything. And it's pretty much how it works. Then to explain the functions is going to be hard. I'm going to have to watch more videos and think about the way that it works at assembly level again, because I think that functions work through loops and through labels, jump labels. That's how function works. And then I was watching videos to remember how hash tables work and array works. So those principles, I think, are for the fundamental principles that I have to teach. And everything else is pretty much a byproduct of that, I think. Then once I talk about all of this stuff, then I can talk about the libraries and then package managers, because those are essential as well. And then once I get to the point, then I can explain the differences between JavaScript and Python. That JavaScript is run in the browser, but it's essentially the same thing. Then I explain the difference between interpreter and compiler. And then I can talk about the nuances of JavaScript. I don't think there's too much stuff to talk about, really, I think, to teach people how to code. The longer parts, I think, are going to be the syntaxes of array methods and objects. I think that's going to be difficult as well, because I'm going to have to research all the methods, and then I think I'm going to talk about as much. I'm going to talk the essential ones first, and then as many as I can in the shortest periods of time possible. But if you think about it, it's not that hard actually to program or to know the essential stuff. The hardest part is getting the practice in, I think, of understanding how everything is connected. That's the most difficult thing, and when to use each thing. But I can't think about a good way to teach people when to think, because that's something I even struggle with to this day, is figuring out what's the right time to use something, and that's extremely hard to teach. So maybe I will reserve this for later videos and try to make videos about that, talking about that once I have more experience. Probably once I get into design stuff, that I'm gonna have to study a lot of things as well, then I can talk about this and the process that I went through and the way that I'm thinking about it now. Yeah, but the idea that I had in my mind was more something where I create a bunch of this, and then, because what I have to explain is that you go from these numbers into, I'm also gonna put another one here, and then put transistor. Yeah, I want to create multiple of this. Then I'm going to talk about how the combination of transistors allows you to create something. Or maybe I should put this more here then. And then I make a circle like this. Logic bit. Yeah, that's the hardest part to explain, which is the arithmetic logic unit. Oh yeah, first I want to talk about, so I'm gonna draw as well a string, and I'm gonna put a bunch of different numbers. Let me finish this first. Then also, let me put some arrows here. Yeah, so I'm gonna use this, I'm gonna explain that transistors, and then I can search for pictures of transistors as well. I don't know if I can incorporate pictures here, but if I can't, I'm just gonna take the picture and then put on top of the thing, as I explain. Or maybe I add it later. Yeah, so I'm gonna put the pictures of transistors here. First thing I'm gonna explain is that the computer is basically a fancy calculator, and that everything you see on the screen is a bunch of pixels that have variations of 3 different numbers that determine colors for red, blue, and green, and the combination of these colors change the format of the screen. So the screen is pretty much a matrix of numbers, and these numbers are changed based on the inputs of the computer, which you can change with the keyboard or the mouse or through the wires that come into your house from the internet that send impulses that are named bits. And then the geometrical structure of the computer through these impulses changes the screen by doing calculations. And that's pretty much what a computer is. So the connection of transistors allows you to create bits of zeros and ones because the transistors are gates for the electromagnetic field. So you can manipulate these impulses of 0 and 1. If it is a 1, it means that the gate is open, which means that electrons are passing. So that's when a transistor acts. So the transistor is kind of like a door. I think I'm gonna use this analogy. So when the door is open, it's considered to be as 1, and when the door is closed, it's considered to be a 0. And then what people have done is combine a bunch of different transistors, and they named this a logic gate, because when you do that, you're able to perform calculations on the, and obviously it's more complex than that, but you're able to design things in such a way that allows you to create sequences of zeros and ones, and that's the binary system. And the binary system is just a convention that we created to be able to make calculations using these impulses. So every place, every spot on the binary system is equivalent to, you could translate that into decimals by multiplying by 2. So each square, each number, I don't know how to say this. I'm gonna have to think about that. How do I say? Each square, each house of these things. Maybe I'll make an analogy and say that each thing here is a house, let's say. Then each time you go to the left, you multiply by 2 to get the equivalent on decimals. And yeah, from these binary impulses, you go from decimals, and then from decimals, you can do calculations based on the numbers. And that is done through something called arithmetic logic unit, which is this structure of logic gates that are designed in such a way that allows you to do these calculations. And the way that the computer stays running, even when there are no impulses, there's always an impulse, which is a voltage that is connected to the computer. But the way that it keeps track of the calculations and what is happening is through something called a clock, which is a system that allows that has a capacitor that now this part is hard to explain. How I'm gonna explain that? As it has a capacitor, then depending on the voltage, it opens and closes the gates. But that's the issue, is that I don't want to make it too complex, because the point is to teach JavaScript and Python, so I don't want to get lost in the details. But at the same time, I want to make sure I don't gloss over this stuff, because it is important, and it's going to make it a lot easier for people to understand how it's actually working. So what I do want to reference is these videos here that he explains, these beginning videos here, where he talks about the circuit that has a capacitor and then resistors, and then it has an SR latch, and that's the frequency. That's how the frequency of the clock is determined, based on the voltage, because the flow of the current. But I don't remember the specific details there. And it's also a little bit too complex, I think, to talk about. Yeah, okay, but I'm gonna talk about that. Maybe I'll just say that it's a clock, and I'm not gonna dive too deep into it. But then from that, arithmetic logic unit, and from the passing of these bits, the structure of these bits, you have these calculations, which are decimals. And then from the decimals, and then what happened, yeah, that's what I want to say. Is that what happened is, because people realized that they were doing the same calculations all the time for specific things they wanted to do. So maybe that's why. So I should put another. Yeah, that's what I want to do. 0, 1. Actually, I should delete this and copy this one. Because I'm gonna say that I'm gonna show these two numbers and then I'm gonna say that they're multiplying. Let's say they were multiplying 2 by 4 all the time, and then to do that in bits. The thing is that I don't want to explain, I don't want to show the bit multiplication because I think that's just a waste of time. It just drags the thing. I just want to get the point across. So maybe I'll just talk about it, but I won't demonstrate the calculation. So just draw it like this, and then when it gets the time, I'll just talk about it. So I'm gonna draw it like this, and then I'm gonna say that from this. So people realized that they were doing the same calculations all the time, so they create rules in order to make it easier to calculate. So instead of doing the calculation, yeah, but then that's the part that is difficult to explain. I'm gonna have to watch the videos again to understand myself better as well. Because the question is how do they? Because what they did was kind of like a meta programming where, and that's the part that is difficult to explain, where instead of doing the calculation directly, they create something that allows the calculation to be run automatically by a symbol instead of putting all the bits. That's the part that is difficult. So instead of doing this process of getting these two numbers and then multiplying them, they created something that gets the number and reverses the process, where you can type 8 directly, and then this thing that they created, maybe I'll just talk about it and don't explain too much in depth because it's obviously more complicated, and then I can make videos about this later once I study more as well. But I want to watch the videos before, so I make sure that that's actually accurate, but I think it is. Yeah, so pretty much this was the flow, is that they started off with transistors that allows you to have zeros or ones, be interpreted as zeros and ones, and then by rearranging these transistors in certain ways, in a certain geometry, you have logic gates, and logic gates allow you to do computation, to do calculation. And then from this calculation, you can translate the binaries into decimals, and that's pretty much everything that a computer is. And then you can store the information based on a clock cycle that is called memory. And you use this memory to perform the calculations as well, to help you perform the calculations. And that's what a computer pretty much is. To have the sequence of steps and memory, and these two things do everything. And then as it got more complex, then people realized they were doing the same stuff, and then they created calculations that do the reverse process, where when you have the impulse of a number, it translates into all the operations that would have to exist in order for that thing to exist. But that's the part I have to think about, a better way to phrase this that doesn't get people confused. But I think I'm gonna have to watch more videos first. How can I do curved arrows? No. No, true. How should do curved arrows in Scrolly Draw? Yeah, but what I want to say is that from this thing here, you get this. So in the first process, they did from scratch, from the binaries, and then they did the calculations directly with the binaries, translating to decimal, and then doing the calculations this way. And then they figure out ways to make it so that you don't have to input the binaries all the time. You can use the binary inputs to create something that allows you to abstract the binaries itself. So once you create the link between the binaries and the symbol, you can use the symbol to get the binaries. And that's the essential part of, that's what programming is essentially. And this process is called a compiler. So a compiler is a set of rules that allows you to decode symbols into binaries again. And once you have that, then you have everything you need, the whole structure for, and then maybe I can talk about stacks and heaps, but I think I'm gonna leave for the next video. And next video after this, I'll talk about stacks and heaps, because I want to keep it as short and concise as possible while explaining as much information as I can without getting too complicated. This process, I have to think more about it, how I'm going to talk about this in a way that makes sense. And I also have to understand it better myself, because it's very hard to find videos that explain this first process. Maybe I will search for the first compiler ever created from machine code to assembly or whatever lower level language. Yeah, but that's pretty much the process. And then I can maybe I can draw a bunch of islands. Yeah, then from this I'm gonna create a bunch of different islands here. I have assembly. And maybe I'll make this smaller. And then I'll copy this. I put the other languages. C, C++. Because I want to represent the idea that I had that compilers are, that if each programming language is like a country, and then compilers are the oceans that connect them, or the bridges that connect them. Then maybe I'll talk about a library here. I think it's gonna be better. And then the next video I'll explain the fundamental structures. And then I'll also explain data structures here, which I'm gonna say that data structures is pretty much just the way that you decide in which way you're gonna store and deal with the data, the memory in the computer. And based on the way that you're deciding to arrange the data, you have different structures, and that's where data structures come from. And then on the other video, I explain heap and stack, and then I will talk about arrays and objects in the differences. And here I can talk about the difference between interpreter and compiler. Just on one song. There's a compiler is pretty much something that doesn't run the code. It just translates the code into binary and then creates an executable, and then interpreter translates and executes at the same time. From the videos I watched, that's what pretty much it is. Okay, so I'm gonna get to this point, and then I'm gonna talk about how they created this set of rules, and then I'm gonna say that that's pretty much everything that exists, and that each programming language is like an island that gets created in the same way that I have countries. Each country, the line between countries is just arbitrary and doesn't exist. It's just an abstraction. So what changes from country to country are the rules and the laws that are created and that decides how people are going to be organized in that space. And that's the difference between them. And it's the same thing with programming languages, where essentially is everything all of the same thing, but from one language into the other, it's kind of like you're creating a different country because you're creating different rules from which the symbols are gonna, the meaning that the symbols have behind them is gonna change because the rules that you decide for each system changes. And the reason why people do that is because they want to specialize the language and the way that you write things and the way that the memory is structured. The way that these symbols are going to become the binaries, which are the structure of the logic gates at the core level, is going to change. And the reason why they do that is because of memory. The way that they want to deal with the memory, which is data structure. So maybe here I'll talk about data structure and algorithms. Stack. I think that's pretty much it. It looks really simple, but I think I can talk about everything because the value comes from the talking and the explaining, and also making it as simple as possible and as straight to the point as possible. But I think that pretty much sums it up, everything, the way that the computer works, and that the stuff that it was hard for me in the beginning to understand, because I started off learning Python and JavaScript, and then the videos talk about the syntax directly, and they don't explain all this stuff here. And then on the other videos, the video after that, I'm going to explain what's a stack and what's a heap, and there are differences in stack and heap from the actual memory. And obviously, I'm going to recommend this guy a lot because his videos are really good. I'm going to watch this video again because I watched this a long time ago, I don't remember. And I want to make sure that I really understand the difference between them in the way that they are structured in memory. So then I'm going to talk about those differences. Then from that point, I think I can talk about explain arrays. I'm gonna show the symbols of arrays and objects, and I'm gonna talk about how they are one of the key essential things. And then I'm gonna talk about how in Python, maybe I won't talk about how in Python everything is an object, because I don't want to get people confused. So I'm gonna talk about these things, and then after that, I think I'll go back to explaining how operators work. I'm gonna explain the assignment operator, so how the equal operator works in memory and what's happening under the hood. And after that, I think I can glance over all the other operators and explain that they are just the same as mathematics. Obviously, there are differences in the way that the whole structure works under the hood to make the logic work, but they mean pretty much the same thing as mathematics, as in mathematics. And then I'm gonna explain the double equality operator and triple equality, and then I might have to explain right away the differences in JavaScript from Python. And that's, yeah, maybe I'll have to explain it right away is better than to go back at the end. So once I do that, I'm gonna have to talk about all the nuances of JavaScript with the zeros and nulls, and then I'm gonna talk about the coalescence operator and why it exists. And yeah, I think I'm gonna break down that. So the fourth video is gonna be stacks and heaps, and then the fifth video I'll talk about other stuff. Explain the assignment operator, and then maybe the nuances of JavaScript in relationship to the operators I'll talk about in the sixth video. And then after I talk about all of this stuff, then I think I can finally get it into the main concepts. Yeah, I think on the seventh video, I'm gonna just break down the main key concepts, which is loops and functions. Loops, functions, classes, and if-else statements. I think those four are pretty much the main ones. And then I'm gonna break them down video by video. And then after I break all of this down, functions is gonna be the difficult one because of scopes. So I'm gonna have to make videos on scopes as well. But after I break all of those down, then I think I can show the syntax and then make videos showing the differences in syntax between JavaScript and Python, between the methods, the array methods and the object methods, and do as many as I can. And then after that, explain more in depth about the differences in classes and the way that they are structured. Yeah, so first I'm going to talk briefly about the concepts just to explain so people don't get lost when I show the code. And when it gets part to do the code, I think I'm gonna do what I was talking about before, which is to put the code, to create a simple code on a file in JavaScript and Python, and then translate the code to here. And then do these arrows here that show like a tree format of arrows that show how each thing is being translated into memory. Oh, I also forgot about the strings. So maybe here I should talk about strings after I talk about the compiler here. Yeah. Yep. This part, I'm not sure about it. I'm trying to think about a good way. Because I want to represent is a bunch of different numbers combined that creates the... Like the vision that I had in my mind is a tree structure, creating the concepts. Let's say 52 or 42. Then I'll create these arrows here. And then I'll explain that this is pretty much a convention that we created in order to represent letters. Instead of using numbers, we can use letters. I'll talk about as ASSC. And UTF-8s. Maybe this is going to be confusing. I think I should make this more distant here, and then just so it's clear that yeah, maybe like this. Is this correct? 27, 33, also has 80. It doesn't really matter if it's correct or not. Yeah, so here I'm going to explain that these together form numbers, and then talk about the how they created the rules to make it easier to write. And that's compilers, and then essentially they have a bunch of different numbers creating more numbers, and it goes on and on. And then in order to represent words, what we did is create a link between the symbols and the letter and the numbers. So the letters don't mean anything intrinsically. We just decided that some of the numbers are going to be equivalent to letters, and that's how the computer understands. So we decided the numbers that are going to be equivalent to the letters. There's no inherent meaning between the link. It's just a convention. And then we can use the letters, the symbols, in order to represent or to make the computer do other stuff based on the same principle of creating rules that allows us to, instead of having to code the bits by bits, we can use a symbol, and then the computer is going to know based on these rule sets that we invented in order to translate the symbol into the signal that we want to represent in memory, which is the structure of logic gates. And then from these rule sets, people keep doing the same thing because that's the evolution of, we are essentially stacking concepts into the computer, because that makes it easier for us to communicate with the computer, because that's how human being works. We simplify reality by compressing the information into concepts, and that's what the process that is happening here. And then through each evolution, there are multiple different programming languages that are created. So essentially there's this link between the data structures at the fundamental level and the syntax that represents the differences based on the rule sets that were created. And that's why the most fundamental things to understand are data structures and algorithms and stack and the heap, because the stack and the heap are two data structures that are used the most in every programming language in order to deal with the set of instructions you're going to be coding into the file in order to make the computer do the calculations you want it to do. And so before all this stuff, I have to talk about, I'll create a cell here, and then I'll create small cells. And I'm gonna put a bunch of different numbers. And I'm gonna use this to explain that, or maybe I should do 3 different numbers on each one. I don't know why it's... I create a cell, create another cell, another here. Maybe this shoe small. Right, sure. Yeah. Okay. I think I'll do this stuff off stream because you get the point. Right, sure. The 57, 4, 15, 81. Yeah, whatever. Fuck. It's annoying because I can't select inside of this. Okay. Bam, bam. Because this was also something that was difficult for me in the beginning. Because I didn't think about the computer as a calculator. To create this link between images and things that are abstract and how they relate to everything else. And the numbers that create this, it seems almost impossible. Because how is it possible that it's just mathematics at the end of the day? You know, a bunch of numbers. But then there's this intrinsic connection between geometry and mathematics because they're pretty much the same thing. Yeah, I'm gonna use this to explain that the computer is just, each cell is a pixel here, and each pixel is determined by 3 different values, which is red, blue, and green. And the color itself is determined by the intensity of the impulse, I think. I'm gonna search for that kind of stuff as well. Maybe I'll talk about it to try to explain how the hell is it possible. Yeah, but I'll talk about this, then I'll talk about transistors. I think that's pretty much it for the 3rd video. It feels like I should be doing some animation or some kind of stuff because I don't know, it seems too simple, but maybe I'm just, maybe this is fine, I think. It's weird. It feels like I'm not putting enough work in for some reason, but maybe it's because of the way that I'm thinking about it in my head. But the problem is I don't know how to translate, how to create the animations. How would I create the animations that I'm thinking about? And I think it would probably just take too long to figure out because I'm not an editor, so I think it's not worth to spend time focusing on that. Then maybe in the future, once I have enough money to invest in or to hire someone to edit the videos, then I can figure that out to make better animations and explain better. But I think for now, it's probably enough to do things like this. yeah, the stuff that I'm thinking in my head is showing the execution of the program. Maybe I'll do that in the future using Python tutor probably. Or maybe I can do that in this video after I talk about all of this stuff. I can open Python tutor and put a simple code and then show the step-by-step thing. Yeah, but I think I'm gonna stop here. That's pretty much it. So I'm gonna record this third video, and then once it gets time to do the fourth one, I come back here and I organize the stuff about the stacking heap. Like I said before, the next one is gonna be about stacking heap, explaining this, and then yeah, then I'll think about the rest. So